All right, here we go. Semester Part 3 notes. This is Chapter 3. This is over systems of equations and inequalities. So the first thing we're going to talk about, if we were to graph these two graphs, you would have to get the y's by themselves. But if you were to graph the two graphs, they would give you two lines. Okay, here's one line, here's two lines, and they would intersect. So the graph of the system, the lines are called intersecting. That means that the point that they intersect at is the solution. This one is 2, 1. Okay, that point is the solution to the system. Since it has a solution, we say the system is consistent. And how many solutions did we have? We just had one solution. When we're talking about those equations, since they graphed different lines, those equations are independent because they were different lines. Okay, the next one, if we graphed these two lines, we would see that these two lines would give us a graph that were two lines that were that looks like this. Okay, what do we call lines that look like this? We call those parallel. Okay, they never touch, they never cross. Okay, if we have two parallel lines, are we going to have a solution? Well, if there's not a point that they share, there won't be an x and a y value that work in both of these equations. So in this case, there's going to be no solution, which you could do that 0 with a slash through it. The system is going to be inconsistent because there is no solution. The type of equations, those are still independent because the lines are two separate lines. They're not the same line. Okay, so if we were to graph this system, you get two lines that are on top of each other. Do you guys remember what those lines are called? Those are coinciding lines. That means they're right on top of each other. Coinciding lines, how many times do they intersect? Well, these two lines intersect at one point. Parallel lines intersect at no points. Coinciding lines share all the points. So, since they share tons of points on that line, there are infinite solutions because a line has infinite points and they share all those points. So, the type of system, we'll say that's consistent because, yes, there are solutions. There's just tons of them. The type of equations, we call those dependent equations because they graph the exact same line. So there's all the vocab. You'll need that on your review assignment and on the semester final, so make sure you know what consistent and inconsistent systems are, what kind of lines they have, the type of solution, and the type of equations. Okay. The next thing we talked about was how to solve systems of equations by graphing, by substitution, and by elimination. So graphing, when you're graphing a system, the first thing you want to do is make sure the y is by itself. In this one, the y is already by itself, so that's great. This one, we have 2y equals 6x minus 4. So to get the y by itself, we have to divide everything by 2. So you get y equals 3x minus 2. So that's our first line. Here's our second line. Now that we have calculators, we can graph it on our calculator. You open a new graph page, we can plug in this one right here, 3x minus 2. Hit graph. We can hit tab to have this drop down again, and we can plug in a negative x plus 6. Here's the other graph. You want to figure out where those intersect because that's where our solution is. So we can hit menu, analyze graph, and then we can go down to intersection. Where do those two graphs intersect? If you can't see the point, you can grab it. You can move that hand over it and then hold it down until it grabs it. And then we'll see that that point is at 2, 4. So 2, 4 is our solution. Our graph looked like this. That was 2, 4. Cool. Substitution, we talked about how you have to have one variable by itself to substitute in. So here the y looks like that would be the easiest one to get by itself. If I'm getting the y by itself, I have to subtract 2x from both sides. So I get y equals 5 minus 2x. The whole point of doing that is now that y is by itself, I know 1y equals 5 minus 2x. So those are the same exact value. That's what the equation says. So that means I can plug in that 5 minus 2x in for y here. So I get 3x minus 3 times y. But I can't solve an equation that has an x and a y in it. So I'm going to plug in this 5 minus 2x in for that y. And all that's equal to 3. The next thing I'm going to do is I'm just going to solve this equation. So I'm going to distribute that negative 3. So you get a 3x minus negative 3 times 5 is a negative 15, so minus 15. Negative 3 times negative 2 is a positive 6, so we got a positive 6x. This 3x and the 6x are on the left side of the equation, so I can combine them, just adding them. 3x plus 6x is 9x, minus 15 equals 3. I'm going to add 15 to both sides. So I get 9x equals 15 plus 3 is 18. Divide by 9. 18 divided by 9 is 2. So I get x equals 2. That's part of our solution. We have an x value, but we don't have a y value. So I'm going to take that 2 and I'm going to plug it in for x in that other equation. We know y equals 5 minus 2 times x, and I just figured out that x was 2. So y minus 2 times 2, or 5 minus 2 times 2, 5 minus 4. So our y value is 1. So our solution here is 2, 1. And you always write it as an ordered pair. The last one is elimination. This is the one where you take the two equations and you stack them on top of each other, and then we're going to add them to each other to hopefully get something to cancel. So this equation I wrote underneath. You want to see what variables, when I add the equations together, would possibly cancel. In order to cancel, they have to have the same number but different signs. So I see right now none of them cancel, but I see this x, this is a positive 2x. I would have to make this x a negative 2x, so I can multiply negative 2 times x and get a negative 2x. So I'm going to distribute that negative 2 across the whole equation. So I have a negative 2x, negative 2 times 2y is a negative 4y, negative 2 times 2 is a negative 4. I'm going to take this first equation and I'm going to write it underneath. So I have 2x plus 3y equals a negative 3. Now I'm going to add those together. Negative 2 plus 2 is no more. They cancel each other out. They eliminate. That's why we call it elimination. You have negative 4y plus 3, so that's a negative 1y. And then negative 4 and a negative 3, that's negative 7. I divide by negative 1, divide by negative 1. I get y equals a negative 7 divided by negative 1 is a positive 7. Once you figure out one variable, you can plug it into one of the original equations to figure out the next one. So I could take 7 and I could plug it in for y here. So I get x plus 2 times 7 equals 2. That's x plus 14 equals 2. And then I subtract 14 from both sides. And I get x equals 2 minus 14 is a negative 12. You write that as an ordered pair, you get a negative 12, 7. Okay, we have a lot to cover, so I'm going to keep moving. Word problems. A hotel has 260 rooms, some single and some doubles. The singles cost $35 and the doubles cost $60. Because of a math teacher's convention, all the hotel rooms are occupied. The sales for the night are $40,000. How many of each type of room does the hotel have? Okay, the first thing you want to do when you're reading a word problem like this and you're asked to set up a system of equations, you want to determine the variables you're going to use. The variables, since it says how many, so we're looking for the number of each type of room. We're going to be looking for the number of single rooms and the number of double rooms. So we could use S for the number of single rooms, and we can use D for the number of double rooms. Okay. The next thing you're going to do is, once you identify your variables, identify any total values. And what I mean by that is anything in the word problem that gives you like a complete number. So in this case, 260 rooms is the total number of rooms they have. There's one total, so we can start with 260. Another total is this 14,000. That's the total sales for the night. That's how much money they make, or how much money they get from all the people staying at their hotel. So those are two totals. From the totals, you want to figure out how to use your variables and other information in the problem to equal that total. Since 260 rooms is talking about the total rooms, you're saying, well, what kinds of rooms do you have to add up to get the total? Well, we have single rooms and we have double rooms. That's all the types of rooms that we have. So the single, the number of S, the number of single rooms, plus D, the number of double rooms, will give us the total amount of rooms. And the next thing is how much money they take in for the night. So we can't just do S plus D, because that would give us how many rooms. But do we know how much each person pays, or the cost of the room? Okay, we know the single rooms cost $35. So 35 times S would give us how much money the single rooms end up taking in for the night. And then the double rooms cost $60. So 60 times D would tell us how much money the double rooms would take in for the night. And when we add those two together, since those are the only types of rooms in that hotel, it would give us the total for tonight. So we're actually not going to solve this. The ones on your semester review are just asking for you to set up the equation. So we have this 260 equals S plus D, and then we have that 14,000 equals 35S plus 60D. Those are your two equations that you have to set up. On the assignment, it just says set up the equations. That's it. You don't have to do anything more. So we're going to end it at that. And to the back. The next two problems are matrices. Just a refresher on matrices. You have to get the x value plus the y value plus the z value equals the number value. You have to get the x, y, and the z in that order, and then the number on the other side of the equation, or else it doesn't work. So when I look at this equation, I see that the negative 15y is, here's my equation. Okay, that negative 15y is on the right side of that equal sign, so I need to move it over. So I add 15y to both sides. So what I'd end up getting is a negative 2x. Then I have to write my y's next, which are positive 15y, and then that plus z, and that'll equal that 44. The next thing on this next equation, I see that my x's need to move over and my z's need to move over. What you'll notice here is anytime you move it over to the other side of the equal sign, it'll change signs. So this negative 4x will become a positive 4x. Then we write our y, so we have a plus 3y. Then this negative z will become a positive 3z, and all that will be left with is that 18. This equation is already in x, y, z form, so I have a negative 3x plus 6y minus a z equals 8. The next thing we need to do is set up our matrix. We're going to have 3 rows and 4 columns, and you're just going to take the coefficients and plug them in. So we got a negative 2, a 15, a 1 in front of this z, and a 44. Then we get a 4, a 3, a 3, and an 18, and a -3, a 6, a -1, and an 8. This negative z is a -1. Then we have to plug this into our calculator using matrix. So we're going to turn it on. You need a calculator page. We're going to hit menu 7, go to matrix and vectors. Then we have to ask for option 5. We're going to ask it to reduce the matrix for us. So we hit enter there. Then you have to plug in a matrix inside that parenthesis. So we're going to hit menu 7, 1. We're going to create a matrix and hit 1 again. We need 3 rows. Then you hit tab and delete. And we need 4 columns, tab and enter. Then we're going to plug in those numbers. The easiest way to plug in the numbers is to enter in a number and then hit tab. That's the easiest way for your cursor to move through all the boxes. So once I enter in all the numbers, you want to double check because you can often make mistakes from going from the equations to the matrix and from the matrix into your calculator. When you hit enter, the answer matrix that you get out of this is 1, 0, 7, 11, 0, 0, 1, 5, 33, 0, and then 0, 0, 0, 1. And normally what you're looking for is this diagonal to be all ones. If it's all ones, then this last column is your solution. But what we see here is this diagonal is not all ones. This last row means that 0x is 0y, 0z equals 1. Well, can 0 equal 1? Nope, it does not work. So this matrix has no solution. Okay, if you get a diagonal of 1s, if we were to do this one, we would get a diagonal of 1s. And you can practice plugging this one in. I'm just going to give you the answers. When you plug in this matrix, you get an answer matrix that looks like this. Okay, you have a diagonal of 1s. What this means is 1x and no y's and no z's equals 4. So our x equals 4, our y equals -1, and our z equals 3. So what you do is you write that as an ordered pair. You have a -4, a -1, and a 6. And actually, that's not an ordered pair, Miss Elmore. That's an ordered triple because we got 3 answers. Okay, that's your ordered triple. All right. Okay, so systems of inequalities. The first thing you need to do when you're graphing a system of inequalities, you need to get the y's by themselves so you can figure out what the slope and the y-intercept is. Remember that y equals mx plus b. M is your slope. B is your y-intercept. Okay, so here when we're getting our y by itself, we have to divide by -2, divide by -2. What that does, when you divide by a negative, your sign has to flip, so we get y is less than, and then at 8x divided by -2 is -4x. If we were to graph this, the slope is the number in front of x, so our slope is -4/1. The y-intercept is the number that's added at the end. Since there's not a number added at the end, it's like a +0. So your y-intercept is at 0, 0. The kind of line that you're going to draw, anytime you have a less than or greater than sign without a equal to sign underneath, it's a dotted line. And anytime they have equal to signs underneath, it's a solid line. So in this case, since it's just a less than sign, we're going to plot a dotted line. And since it's a less than sign, anytime it's a less than sign, you shade below. And anytime it's a greater than sign, you shade above the line. Since ours is a less than sign because we had to flip the sign because we divided, we're going to shade below. So if I were to graph this, my y-intercept is at 0, 0. My slope is a -1, 2, 3, 4/1. So you're going down 4 into the right one. If you run out of room, you can go the opposite way, up 4 and over 1. And it's a dotted line. So you connect those with dots or dashes, and then we shade below. Okay, from there, let's solve this other one. The y is having 2 added to it, so we need to move the 2 to the other side, so we need to subtract 2. So we get y is greater than or equal to x minus 2. From here, the y is by itself, so the next thing we're going to do is figure out what our slope is. The slope is the number in front of x, which is an invisible 1. So our slope is going to be 1 over 1. The y-intercept is at -2, so it's going to be 0, -2. The type of line, since it has an equal to sign, we're going to have a solid line. And where we're going to shade, since it's a greater than sign, we're going to shade above. So our y-intercept, that's where you start, is at -2, so I'm going to go down to -2 and plot my point. The slope is 1 over 1, so I'm going to go up 1 over 1, rise up to the right 1, rise over 1. It's a solid line, so I get to connect those dots with the solid line, and then I get to shade above. So I'm going to shade up here. Now remember that the solution to this inequality, all the points that are where those lines overlap or where the shading overlaps is your solution. So you want to make sure you color the shaded area where they overlap darker so you can tell. Okay, go ahead and try B on your own and see if you get what I get. First thing here, we need to subtract. We need to get the y by itself. So subtract x on both sides. So we get -2y is greater than, I'm going to write my x's first, -x plus 6. Divide by -2, divide by -2, divide by -2. So I get y is less than, a negative divided by negative is a positive, and this is like a 1 over 2, so it's going to be a positive 1/2 x. 6 divided by -2 is -3. So if I fill this in here, my slope is 1/2. My y-intercept is 0, 3, -3. The line is going to be dotted because it doesn't have an equal to sign, and since it's less than, we're going to shade below. On this one, I'm going to subtract x. So I get 4y is less than a -x minus 4. I'm going to divide by 4. I get y is less than a -1/4 x. And -4 divided by 4 is a -1. So my slope is a -1/4. My y-intercept is that -1. That's all by itself right here. The line is going to be dotted, and I'm going to shade. Again, it's a less than sign, so I'm going to shade below. So from here, let's plot this line first. We got a 0, -3, slope of 1/2, so you're going up 1 over 2, up 1 over 2, a dotted line, and we're shading below. The next one is at 0, -1, slope of -1/4, so I always put the negative sign with the top number, so I go down, then over 1, 2, 3, 4. If you run out of room, you go the opposite way, so I'm going to go up and to the left, 1, 2, 3, 4. This is also a dotted line, and it's also shaded below. So where do my two shaded areas overlap? They overlap in this section right here. So that's what we color darker. That is the end of semester review part 3. Work hard.